Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I am going to continue with your same module, that is the object-oriented programming, as well as the same chapter, that is chapter number 4, that is a continuation of chapter number 4, that is functions in C++. In the last class we have started this chapter, that is what is the functions and what is the role of function in C++. What are the various advantages of C++, what are the various types of functions in C++. So now let's continue the session. So let's take a quick review what we have covered in the last class, then moves to the today's topic, that is the function overloading, that we have not covered in the yesterday's class. We will take for the today's class only. So let's start with the chapter number 4, that is let's start the last class session, that is the chapter number 4, functions in C++. In this chapter we have studied so many rules, like what is the return type of the main function, what is the function prototyping, call by reference, call by structure. This is the function declaration. This is the basic. That is, first of all, there is a void show. That is, first of all, there is a function declaration. Then there is a main. That is the main function. Then there is a function calling. So there are three parts. One is a function declaration, one is a function calling, and one is a function definition. Function declaration means declaring the function at the top of the void main. That is, at the top of the main function there is a function that is declared, that is known as the function declaration. Second, in the main, when the function is called to the when the function is calling, that is known as the function call, that is the show. And when the function is defined, that is what is the role of the function, what does the function contain, that is known as the function definition. These are the three parts. One is the function declaration, one is the function call, and one is the function definition. Then this is the function body, that is after the definition, or in the definition we are giving the function body. Then we studied about the main function, that is like the starting point, or that is like the entry point of the program. That is, during the execution of the program, main function is the entry point from where the program begins. That is the starting point for execution of the program, that is known as the main function. Then this is the syntax, that is main program statements. This is perfectly valid because the main in C does not return anything, but in C++ there is a int main. So there is a return statement that is mandatory, that is known as or that is done by the return 0. So in C++ we use the int main and there is a return 0. And these are the various properties. Then we have studied about the function prototyping. That is, what is the function prototyping, how the function prototyping is used, or how the function of prototyping is beneficial in the operator overloading and the function overloading. So function overloading is one of the major improvement, one of the major additional feature that is available in C++ function. The prototype describes the function interface to the compiler by giving the details. What are the various details? Such as the number and the type of arguments and the type of return types. That is, first of all, whatever the function, whatever the argument, whatever the functions, whatever the data type given in the parenthesis, that is a number and the type of arguments and the type of return values. With function prototype, a template is always used while declaring and defining a function. And when the function is called, the compiler uses the template to ensure that proper arguments are passed and the return value is treated correctly. Remember, C also uses the prototyping. That is, C also uses the prototyping, and this is a function prototype, that is a function declaration, that is the syntax of function declaration. First of all, there is a type, that is a return type. Then there is a function name. So first of all, there is a type, then function name, then argument list. The argument list contains the types and the names of the argument, and that must be passed to the function. Then this is an example, that is float, volume, index, float y, float z. And this is the illegal one. Why? Because we cannot use more than one variable with the same data type. No, we have to define the separate data type for separate variables. That is the function declaration. So this is the syntax, this is the structure of the function declaration. Then we have studied about the call by reference. That is, what with call by reference? So whenever we pass the addresses or whenever we use the calling function that passes the address, that is known as the call by reference. So in traditional C, a function calls passes the argument by value. The call function creates a new set of variable and copies the value of argument into them. The function does not have access to the actual argument, actual variables in the calling program, and can only work on the copies of the value. This mechanism is known as the calling function. That is, when we call the function, there is an argument that is passed. There is just a photocopy of the main argument or the main function or the main variables. So in call by value, whenever there is any change in the value, that does not impact on the value that is changed in the formal argument. But when we use a call by reference, any value that is changed in the formal arguments must be reflected in the actual argument. That is a call by reference. Then next is return by reference. That is the next one. That is how to return by using the reference. That is using the addresses, how to return the values. Then next is inline function. That is what is the use of inline functions. That is one of the function or any function that is defined in only one line, that is known as the inline function. So one of the objective of using function is to save the memory space, which become appreciable when the function is likely to be called many times. So what is the main advantage of using the function? The main advantage is to save the time, or the main target is to save the time, save the energy, save the memory space. So whenever we use the same function again and again for executing a program, so it saves the time, it saves the memory. So one solution that is given to the problem that is given or that is described, that is using the inline function. Inline functions are those functions that is defined in only one line. So that is, and that means the definition is defined in the same way or at the same place when the function is called. So the inline function are defined as follows. That is the inline function header, function body. This is the example. That is the inline double cube double A. The above inline function can be invoked by using the statements like this one. Some of the situations where inline functions, where inline expansion may not work. So what are the various conditions in which the inline function cannot work? When the function returns a value, or if we are using, or if a loop, switch, or the go to exist. And another scenario is that for functions not returning values if a return statement exists. Then if a function contains static variable and if the inline functions are recursive. So these are the various situations, conditions where the inline function may not work. This is the example that we have discussed about the inline function, that is how inline function will be used for the multiply and how inline function will be used for the divide, and it is available in only one line or one or two lines. So that is, or inline functions are very short function that is defined in one or two lines. So it's better to define them the place, or it is better to define them at the place where it is called. So whenever it is called, it is defined in that place only. Then next is default argument. That is, what are the default argument? That means when the parameters or when the argument takes the value by their own, that is known as the default argument. So when we do not specify any argument, in such cases the function assigned or assigns a default value to the parameter which does not have a matching argument in the function call. Then next is your constant argument. That is, what is the role of the constant argument? That is, constant argument means using the constant variables, using the constant functions as an arguments. Now next is function overloading. Now let's start with the today's session, that is a function overloading. So overloading means using the same function at the same time. That is, overloading refers to the use of the same thing for different purposes. That is, the same thing is used but the purpose is different. That is, the usage of the same thing for different purposes. C++ also permits the overloading of the functions. That is, using the same function name and it is defined or it is available with the different purposes. So as stated above or as stated earlier, overloading refers to the use of the same thing for different purposes. C++ also permits overloading of the function. That is, C++ also allows the overloading of functions. This means that we can use the same function name to create function that performs a variety of different tasks. That is, the same function name is used but with different argument list. That means, or this means, we can use the same function name to create the functions that perform a variety of different tasks. This is known as function or function overloading or function polymorphism in OOP, that is the object oriented programming. So function overloading means overloading the function, uses the function with the same name, or uses the function with the um, same name but with a different arguments list. That is known as the function overloading. So using the concept of function overloading, we can design a family of functions with one function name but with different argument list. As we said, the function would perform different operations depending on the argument list in the function call. So this function that will perform different operations, different methods that is used depending upon the argument list that is used in the function call. The correct function to be invoked is determined by checking the number and the type of arguments. Suppose we have used a function that is a function calling in which there are four types of argument, and two are of int type and two are of double type. So in such a case, whenever the formal arguments are used, then they match the first of all the number and the type of argument. If they are matching, then only the function will be called. Otherwise, the function is not called. So the correct function is invoked whenever the type and the number of arguments are matching with the number and the type of argument that is given in the actual argument. For example, this is an overloaded function that handles different types of data. This is the same function name. A double D is same in everywhere. That is A double D, A double D, A double D. So add is a function that is used, that is the A double D. Then this is the return type. What is the return type? That is the int. So int add, and then there is a parenthesis, then int a comma int b. That means what are the argument list, what are the prototype list? That is the int a and the int b. And add is a function name. Then next is int add, int a comma int b comma int c. That is this is the argument list that contains three variables, that is the three data type and the three variables. Then double add, that is return type is double and a double d is the function name. Then argument list is double x and the double y. Then double add, that is the int p and the double q. Then double add, double p and the int q. So these are the various function that uses the same function name, that is a add, but with different argument list, but with different prototype. That is a return type is also different, type is also different, argument is also different, and the variables are also different. So these are the examples of function overloading. Now these are the various declarations. Now there is a function call. How it is used? So it depends on the it depends on the type and the number of argument used. Here cout at 510, both are of integer value, so it is using the first function, that is the first int a comma int b, that is 5 comma 10. That is the addition of the two integers. Now it is the addition of three integers, that is the abc. So this is 15, 10.0. This is not used. So this is the int and the float. Now where is the int and the float, or int and the double? So this is the case where int and the double, so it uses the prototype 4. So this is mentioned, uses the prototype 4. How I know that how it is used the prototype 4? Because one is of int and one is of double. Here one is of int, one is of double, right? Then this is double, this is double, this is double, this is double, that is prototype 3. Then int, that is prototype 2, that is int a, int b, int c. Then double and the int, that is prototype 5, that is a double, that is 0.75, and the int, that is a 5. A function call first matches the prototype having the same number and the type of arguments, and then call the appropriate function for execution. So whenever a function calls, or whenever a function is defined that calls, first matches the prototype. That is, it first of all matches the prototype, that is the number and the type of argument used, having the same number and the type of arguments, and then calls the appropriate function for execution. So first of all it defines, or it matches the argument, it matches the data types. If the data type is matched, the arguments are matched, then only it is used for the execution. Then calls the appropriate function for the execution. A best match must be unique. The function selection involves the following steps. So how it matches the various functions, how it will, or how the compiler know that which function is to call, either it may be int, may be double. So what are the various steps? The first step is the compiler first tries to find out the exact match in which the type of actual argument are the same and use that function. That means first of all the type is matched, that is the data type is matched. If the data type is matched, then only the function will call. And if the exact match is not found, suppose there are int and it is available in double, so that is the exact match is not found, that is only one match is found, that is of int, then the compiler uses the integral promotions to the actual arguments, such as char to int or float to double. That is, it uses the integral promotion, means integral part of the actual argument to the actual argument to find a match. Then third point says, when either of them fails, that is either first part or the second part become fails, that is if the compiler tries to find out the exact match, that is not available, that is also fails. In the same way, when there is a compilation, when there is a duplication, when there is a conversion from one data type to another data type, that also fails. So when either of the one of them fails, the compiler tries to use the built-in conversion. Built-in conversion means that is already built conversion that is used through the actual argument and then uses a function whose match is unique. That means it is based on the conversion, it is based on the implicit conversion that uses the match. So it defines a function, it uses the function depending on the similar data type, similar argument list, similar different. So suppose we use the following two functions, that is a long square, long n, double square, double x. This is the example that shows the function overloading, that is the function volume is overloaded 3 times, that is 3 times it is overloaded. So first of all, hash include iostream, that is the first header file that is used. Then using namespace std. Then declarations, that is what are the declarations, that is the prototypes. Then these are the 3 declarations, that is a prototype. So first of all, there is a function that has a return type int as well as the argument type is also int, that is int volume int. Then double volume double int, that is the return type is double but the argument it takes is one of the double and one of the int. Then long volume long int int, that is the return type is long, that is in the decimal place, but the argument that is used is long int int, that is one is of decimal part, one two of integer part, that is the discrete values. Now this is the function declaration, this is the function or int main function. First of all, it uses the volume 10, that is only uses the integer value. Then double and the int, that is 2.5 and 8. Then long int int, that is the next part, that is 100 L means long, that is L, then int and then int. Then there is a return 0. So whenever this will use, the cursor directly moves to integer part, that is the int part. So this is the first part, that is the definition. So whenever there is a first argument, first line, that is volume 10, the cursor directly moves to this part, that is int volume int s. Then there is a return type, that is s into s into s, that is the same value or the same volume or the same argument is multiplied by 3 times, that is 10 into 10 into 10, that gives the output as a 1000. That is a 10 into 10 into 10. Why? Because it is of integer part and the definition says multiply the number by the 3 times, that is a 10 into 10 into 10. Then next is double volume, that is the next part, then double r int h. Then there is a return, that is 3.14 into r into r into h. This is the formula that is used, that is 2.5 into 3.14 into 2.5 into 8. Because double is of r, that is a 2.5 is of r. Then next is long volume, long L into B into H. Then return L into B into H. This is the output that is given. One is 1000, then 157.26, then 1.2500. So this is the function overloading, that is the same function name is used for different argument list and with different return type, that is a function overloading. But overloading can be done in a very crucial way, that is it can be done in a very crucial way how it is used. what are the various questions, what are the various uses that is used. The first is we should not overload unrelated functions and should reverse or reserve the function overloading for the various functions that performs closely related tasks. That is, we should not overload the unrelated function, that is unrelated function that is not related with each other, we should not overload them, and reserves the function overloading for functions that performs a closely related task. Sometimes the default argument may be used instead of overloading. This may reduces the number of functions to be defined. Overloaded functions are extensively used for handling class objects. They will be illustrated later when the classes are discussed in the next chapter. So there is the next chapter, chapter number 5, when the classes are discussed. Then next topic is friend and the virtual function. That is, what is the friend function, what is the virtual function. Now, what is a friend function? As a name advises, friend function or the friend class. So when the one class is introduced with another class, that is known as the friend function. So this is C++ introduces two new types of function. That is, there are two new types of functions in C++, namely friend function and the virtual function. They are basically introduced to handle some specific task that is related to class object. Therefore, discussions on these functions have been reserved until after the class objects are discussed. That is your friend function. That is the next chapter. In next chapter, it will discuss like a friend function and the virtual function. The next function is math library function that is used. That is the math library functions. So the standard C++ supports many math functions that can be used for performing certain commonly used calculations. Most commonly used math library functions are summarized in table 4.1. That is a commonly used math library functions. So one is the ceil function, that is a ceil that rounds off to the smallest integer. Then cos function, that is a trigonometric function. Then exponent function, that is exponential function. Then floor function, log function. So these are the various mathematical function that is used with the various function argument list. The argument variables x and y are of type double, and all the functions returns the data of the type double. To use the math library functions, we must include the header file, that is the math.h in conventional C++ and cmath in ANSI C++. So to use the math library function, we must include the header files. Now this is the summary, that is the winding of the chapter, that is summary of this chapter. So first point says it is possible to reduce the size of the program by calling and using functions at different places in a program. So it is possible to reduce the size of the program. That is, the same program is divided into multiple parts, that is dividing the or reducing the size of the program by using various functions. Then next point says in C++ the main function returns a value of the type int to the operating system. Since the return type of function is int by default, the keyword int in the main header is optional. Then function prototyping gives the compiler the details about the function, such as number and the type of arguments and the type of return values. Then next is reference variables in C++ permit us to pass parameters to the function by reference. A function can also return a reference to a variable. Next, when a function is declared inline, that is when the function is inline function, then the compiler replaces the function call with the respective function code. Then the compiler may ignore the inline declaration if the function declaration is too large or too complicated. Next point says C++ allows us to assign default values to the function parameters when the function is declared. That is, it allows us to assign the default values to the function parameters when the function is declared. Next point says in C++ an argument to a function. So whenever we give the argument to a function as a constant, that indicates that it should not modify the, or the function should not modify the argument. That becomes, or the values become constant. C++ allows function overloading. That is what is the function overloading? That is using the same function with the, or using the same function name but with different argument list. That is, we can have more than one function with the same name in our program. The compiler matches the function call with the exact function code by checking the number and the type of the arguments. C++ supports two new type of function. That is, it provides a two new types of function. That is a friend function and the virtual function. Many mathematical computations can be carried out using the library functions that is supported by the C++ standard library. Now, these are the various key terms that is used in this chapter. That is how it is used. That is the mat.h inline function. And these are the various true-false questions. So let's discuss these questions. This point says D point, a function can return a value by reference. So it is also possible to return the value by a function in the form of reference. That is, we can return the address part also. This is true or false. This is true. We can return the address part also with the help of a function. Next, first point says a function argument is a value that is returned by the function to the calling function. So it is a value that is returned by the function. No, argument is passed to the function when it is defined. Answer is false. Last point says it is not necessary to specify the variable name in the function prototype. So if I declare, or if I declare only int in the function prototype, it is sufficient. Yeah, it is sufficient, because the compiler only takes care of the data type, not takes care of the variable name, but it takes care of the variable name in the function definition, not in the function declaration or function calling, because function prototype means whenever the function is called. Next question is advantages of function prototyping. Now find out the errors, if any, in the following. So this is a question that is based on the errors. The first is float average xy. Now if there is any error, that is a float average, that is average of function, and float is return type, and there are two arguments, x and y. Is there any error? Yeah, there is any error. Or there is an error. Why? Because the x and y is mentioned only, not that the data type is mentioned, only the variable name is mentioned. So it's mandatory to use the variable name. So this is not okay. Why? Because it's mandatory to use the variable name or data type, that is the int. So it is either of int, it is either of double. Then next is int mul int ab. So it is also a function, that is int mul means multiply is the function, and int means that is a return type, and there are two variables that is used, that is a int a comma b. So it is also okay, that is a comma b, that is also used, that is a int a comma b. Then next is int display, that is a display is a function that is used, then there is a blank, that is also true. So first two are errors, because we have to define the separate data type for separate variables. So first two are gives the error, but third last one is true, that does not give any errors. Now next question is when will you make a function inline? Why? What is the usage of inline function? So whenever I want that my function is a short function to save the memory, then we use the inline functions. So these are the various questions that is used, these are the various debugging exercise. Now comes to the chapter number 5, that is the classes and the objects. So that is chapter number 5. What is the meaning of class? What is the meaning of objects? What is the relationship between the object and the class, and how we can define the classes? So what is a class? As I said earlier, class is a combination, or class is a wrapping of data members and functions. That is, whenever we combine the data members and the functions, that is known as the class. So that is the wrapping of the data members or functions in a single unit, that is done by the class. So class means wrapping of the data members and the functions. So these are the various key concepts that is used in this chapter, that is structures, creating a class, defining the member functions, creating the objects, using the objects, in inline member functions, nested member functions. These are the various key concepts that is available in this chapter. So let's start with the classes and the objects. The most important feature of C++ is class. As I said, C++ is one of the important features that is available in object-oriented programming. Its significance is highlighted by the fact that Struct initially gives the name C++ with or C with the classes. That is, whenever we use the C++, so the builder, the manufacturer, that is the Struct gives the name as a C with the classes. That is, using the C with the various classes, that is also known as a C++. A class is an extension of the idea of the structure used in C++. It is just like a structure that is used in C. That is a user-defined data type, but it gives more functionality as compared to the structure in the C. It is a new way of creating and implementing a user-defined data type. So it is a new way, new method of defining, of creating and implementing a user-defined data type. We shall discuss in this chapter the concept of class by first reviewing the traditional structure that is used in the C. So first of all, review the structure that is used in the C, then moves to the C++ part, that is how or what is the class and how it is used. So first reviewing the traditional structure found in C, and then the ways in which classes can be designed, implemented and applied. Now next is first of all, next topic is C++ structures revised, that is revisited. That is, first of all, revisit the C++ or C structure, not C++. C++ have a class, but the C have a structure. So what is the structure in C? As I told you, that structure is a user-defined data type. That is, we can define the data according to our need. For example, if I need the int, char and the float, both three characters or both three data types of one variable. So we can define int a, char b and the float c. Anyway we can define. They provide a method, that is a structure provide a method for packing together of different types. As I said, it is a user-defined data type that contains the value of different types. A structure is a convenient tool for handling a group of logically related data items. So it is a convenient tool or a best method for handling a group of logically related data items. It is a user-defined data type. As I said, it is a user-defined data type with a template that serves to define its data properties. Once the structure type has been defined, we can create variables of that type using declaration that is very similar to the built-in declaration. So once we have created the structure, we have to define, or we are able to define the variables of the structure that are known as the structure objects. For example, this is the declaration. So first of all, there is a struct, that is a keyword, and the name of the structure is student. Then there is a char, that means the string that is of taken place, that is of name, that is of 20 characters. So it starts with a 0, it ends with the 19. And remember, it is also terminated by the null characters. Then next is int roll number, that is taking the roll number as an integer value. Then name has already mentioned, that is student name, roll number. Now float total marks, because the marks may be in a percentage, maybe in a decimal form, so the float total marks. And then closes the semicolon, and then closes the curly braces, and then there is a semicolon. This is a semicolon. So first of all, there is a struct student, that is a student structure, the name, roll number, total marks, and the structure will close, and there is a semicolon that is terminated the structure. The keyword struct defines or declares student as a new data type that can hold 3 fields of different data types. These fields are known as structure member or the elements. So these are known as the structure member or the elements. The identifier student, which is refers to as a structure name or structure tag, can be used to create variables of type student. For example, this is the example. That is a struct student A, that is a C declaration, that is how to declare, that is a struct student A. A is a variable of the type student and has 3 member variables that are defined by the template. That is, A is a variable of the type structure student. Member variable can be accessed using the dot operator. This is what we have covered in the structure. That is, if I want to access the data members, if I want to access the member variables using structures in C, that can be accessed by using the dot operator or the period operator, that is the arrow operator. So this is strcpy, that is used for the copy. Then there is the a dot name, that is referring the or accessing the structure with the use of the dot operator, because a is the variable of the structure, that is a. Then dot name, then John, that is the name of the student. Then a dot roll number equals to 999, that is the roll number is 999. Then a dot total marks equals to 595.5, that is also in a float, because it is mentioned in a float, that is a 595.5, that is a 595.5, that is in a float. Then final total equals to a total marks plus 5. What is the final total marks? That is the a total marks, this is plus 5, that is the grace marks. So in simple terms, what we have covered in structure, that is a user defined data type that has a data member, that is a structure member, structure elements. And whenever we declare the structure, whenever we use the structure, whenever we declare or uses the structure, that can be defined or that can be accessed, or we can define the variables of the structure. For example, define the structure as a, and using the dot operator we can access the structure elements. Now, what are the limitations of C structure? The standard C does not allow the struct data type to be treated like built-in type. For example, consider the following structure. This is a struct, that is a complex, then float x, float y. So complex is a structure name, and there are two structure members, that is a float and x and the float y. Then the structure will close, that is the closing of the structure, that is a curly braces, and there is a closing of the structure. The struct complex C1, C2, C3. That is, three variables are declared, or three variables have been declared of the struct type complex, that is C1, C2 and C3. The complex numbers, that is C1, C2 and C3, can easily be assigned values using the dot operators. But we cannot add two complex number or subtract one of the another. That is illegal. That is, if I have to define, or if I have to use the dot using the dot operator, if I have to use any operations on the variables of the structure, that is C1, C2, it is not possible to assign the operations on the structure elements. That is also illegal in C. This is one of the limitations of the C structure. Another limitation is they do not permit the data hiding, that the data is easily accessed by anyone, that is data is not hidden in the structures in C language. That is, the structure elements can be easily be accessed by the structure variable by any function. That is, whatever the structure member, for example in this one, name, marks, roll number, it can be accessed by any function that is anywhere in the scope. So data is not hidden, or data is accessible by anywhere at anyone. In other words, the structure members are public members. So there are two limitations, that is, we cannot perform the operations on the variables of the structures. Another limitation is that it does not allow the data hiding, that is, the data is available to the public members, or data is available publicly to the members. Now, there is an extension to structure, that is a improvement of the structure, that is a advancement of the structure. So C++ supports all the features of the structure as defined in C. So C++ have all the features of the structure, or C++ supports every feature that is given by the structure in C. But C++ so sorry, has expanded its capability further to suit its object-oriented programming philosophy. It attempts to bring the user-defined data types as close as possible to the built-in data type. That is, it attempts to bring, or it takes the user-defined data type as close as the possible to the built-in data types, and also provides a facility to hide the data, which is one of the major principle, one of the main principle of OOPS, that is the object-oriented programming. Inheritance, that is a mechanism by which one type can inherit the characteristics from other type, is also supported by the C++. Inheritance is also a method by which the one type is supported or one type takes the properties of from another type. That is also supported by the C++. In C++, a structure can have both the variable and the functions as members. It can also declare some of the members as private, so that cannot be accessed directly by the external function. That is, in C++, a structure can have both the variable and the functions as the members. It can also declare some of the member function as a private that cannot be accessed directly by the external function. So it provides the data hiding. In C++, the structure names are standalone and can be used like any other variable name. This is the structure or student A. The only difference between structure and classes in C++ is that by default the members of a class are private. So whenever we declare the class, by default every member of the class is private, whereas in the structure the default or by default the member of a structure are public. That is, there is no data hiding in the structure, but there is a data hiding in the classes. That is, the members of a class are private and the members of the structure are public. So one is private and one is public. Then next is specifying a class. That is, specify a class, what is a class, how it is used, and how we can use the class. That is specifying a class. So class is a new way to bind the data and its associated function together. So what is a class? If anyone can tell you what is a class, so it is a way to bind the data. It is a way to merge the data into a single unit. So it is a way to bind the data and its associated functions together. Not only the data, but also the data members as well as the member functions together. It allows the data and the functions to be hidden if necessary from external usage. When defining a class, we are creating a new abstract data type that can be treated like any other built-in data type. Generally, a class specification has two parts. Generally, a class has two parts. One is the class declaration and one is the class function definition. So there are two parts. One is the class function definition, one is the class declaration. The class declaration describes the type and the scope of its member. That is, what is the type and what is the scope of the member. That is a class declaration. The class function definition describes how the class functions are implemented. So one defines what is the type and what is the scope of the members of the class. One defines that how it is used or how the class functions are implemented. That is, what is the role or what is the role of the every function, what is the role of the various integer that is used in C++, that is used in the class. So the class declaration, that means that defines the type and the scope of its members, and the class function that defines the class function and or how the class functions are implemented. Then this is a general form of a class declaration. There is a class, then there is a class name. Then that means the class is a keyword and class name is the name of the class. Then there is a private, that means the declaration of the data members. That means the private part, it is declared in a private as well as the public. These are the modes. So one is private, one is public, and one more is that is a protected. So there is a private, then there is a variable declaration, then there is a function declaration. So there are two parts in private also. So we can define the members, that is the data members, that is a variable declaration. Also we can define the function declaration, that is the member functions. And in the same way, publicly we can define the variables so that it can be accessed by anyone. But in the case of private, it cannot be accessed by anyone. In the same way, in public there is a function declaration. And then there is a closing of the class, and then there is a semicolon. The class declaration is similar to the struct declaration. The keyword class specifies that what follows is an abstract type of class name. The body of a class is enclosed within braces. It is enclosed within a braces with a semicolon and terminated by a semicolon. The class body contains the declaration of the variables and the function. These functions and variables are collectively known as the class members. So if I combine the class, if I combine the various members, various functions and the variables, like variable declaration, function declaration that are collectively known as the class members. They are usually grouped under two sections, namely the private and the public, to denote which of the members are private and which of the members are public. The keyword private and public are known as the visibility levels. So if we say that the modes, if we say that the visibility levels, no issues, both are the same name, that is the visibility levels. Note that these keywords are followed by a semicolon. That is this keyword that is followed by a colon, not semicolon, this is the colon. The class member that have been declared as private can be accessed only from within the class. As I told you, whenever the visibility level is private, that can be accessed, or the members can be accessed privately, that can be accessed from within the class, that is anywhere. Sorry. So whenever we declare the class as a private, visibility level as a private, so it can be accessed only within the class. Not any other class or not beyond the class, it can be accessed, but it can be accessed only within the class. On the other hand, public members can be accessed from outside the class also. So in case of the outside members, in case of the public member, that is the visibility level is public, that can be accessed, that is outside the class also. It's not foundation that it is accessed within the class. No, it can be accessed from outside the class also. The data hiding is a key feature of object-oriented programming. The use of the keyword private is optional. That is, use of the keyword that is a private is optional. By default, the members of a class are private. If both the labels are missing, then by default all the members are private. That is, the by default the members of a class are private and the data members are and the member of functions are public. But if both the labels are missing, that everyone is private. Such a class is completely hidden from the outside world. That is, no one can access the data members as well as the function, that is the member functions. The variable that is declared inside the class are known as the data member, and the functions are known as the member function. So whatever the variable that is declared, that is known as the data members. Whatever the function that is declared, that is known as the member functions. Only the member functions can have access to the private data. That is, only the functions that is declared inside the class, they have access to access the, or they have a capability to access the data members. However, the public members, that is both the functions and the data, can be accessed from outside the class. The binding of data and functions together. So whenever we bind the functions and the data, whenever we bind the functions, or whenever we bind the data members as well as the member functions together into a single class, that is known as the encapsulation. This is the data hiding in the class. There is a private part, that is the data and the function. This is the public, that is the data and the function. There is a class that contains both the private part as well as the public part. And in public there are two types. One is the data members, one is the member functions. In the public there are also two parts. One is the data members, one is the member functions. There is a no entry to the private data. This is the entry allowed to the private data. Now this is just a simple example of class. So first of all, let's take a break, then move to the simple example. Let's discuss what is the example, what is the meaning of this example, right? So first of all, let's take a break, then move to this example, that is the class example. So let's take a break right now. So come back from the break. Now let's start the session again. So this is the example of the class, that how the class will be used. That is a simple class example. Right, so this is the class item, so that is a class name, that is the item. Then there are two parts, that is of public, that is of private, because nothing is mentioned, so that is of private part. So what are the two parts? One is the number, one is the cost. Number is of integer type and the cost is of float type. So there are two parts, one is the number, one is the cost. And number is of integer type, that is, it is a variable declaration, that is the number is of integer type, and the cost is a float type, that is a variable declaration, that is by default it is a private. Then there is a public, that means for public members, that is a void get data, that is the data get data is the name of the function that is used, and there are two arguments, there are two functions that is used. One is the a, one is the b, and a is of integer type and b is of float type. There are two parts, one is the a, one is the b, and the a is of integer part, float is of, and b is of float part. That is a function declaration, that is a public part, that is anyone can access it, whether within the class, whether beyond the class. Then void put data, void, that is the return type is void, as well as the default argument or the argument that is used is also void, that is using the prototype. So there are two functions that is used. One is the get data, one is the put data, right? That is also part of the public. And that there is a closing of the class, that is closing by the curly braces, and there is a semicolon, that means termination of the class. So one is the class name is item, that is then declare two data members, then declare two member functions, that is a two function that is used, that is a public part, that is get data and the put data, and then the closing of the class, and then the closing. After closing there is a semicolon that ends with the semicolon. We usually gives a class some meaningful name such as the item. This name now becomes a new type identifier that can be used to declare instances of that class type. The class item contains two data members and two member functions. The data members are private by default, while both the functions are public by declaration. That is, the data member that is given are private by default, while both the functions are public by declaration. The function getData can be used to assign the values to the member variable number and the cost, and putData is used for the displaying their value. That is, two member functions are used. One is the getData, one is the putData. GetData is used to getting the values or assigning the values to the various member variables, and the putData is used for displaying their values, displaying the data on the screen. These functions may be used, or these functions may be used for calling the function, for defining the function. So these functions provides the only access to the data member from outside the class. This means that the data cannot be accessed by any function that is not a member of the class item. Note that the functions are declared, not defined. So functions are declared, not defined over here. That is, declare means declaring the function, not defined over here. Remember it carefully. Actual functions definition will appear later in the program. The data member are usually declared as a private. That is, in general, the data members are usually, or in general, it is declared as a private, and the member functions are usually declared as a public. Why? Because the data members can be accessed within the class only, and with the help of the member function, that is a public part, we can access the data member, that is a private part. And now there is a class creating an object, that is next topic, that is how to create the object using classes. Remember that the declaration of item, that is the class item, has shown does not define any object of item, but only specified what they will contain. Once a data has been declared, so once a class has been declared, so once we have declared the class, that is what are the data members and what are the member functions, we can create variables of that type by using the class name, like any other built-in variable. For example, this is the example. There is a class, then there is an item, then there is a data, that is a number and the cost, and the functions are get data and the put data. Then there is a get data, then there is a put data, that is of item part, that is a representation of a class. Then this is the item x, that means the item is the name of the class and x is the variable that is used. So the memory is allocated, or memory is created for the x. So memory for x is created. So it creates a variable x of type item. In C++, the class variables are known as the object. So in C++, whatever the variable that is used with the class, that are known as the object. Therefore x is an object of the type item. So x is the object that is of the class item. We may also declare more than one object in one statement. Example, item x, y, z. So there are three variables that is used, and item is the name of the class. The declaration of an object is similar to that of the variable of any basic type. The necessary memory space is allocated to an object at this stage. Note that the class specification, like a structure, provides a template, not only provides a template, but does not create any memory space for the object. That is, whenever we specify the class, that is the class specification, like a structure, provide the template but not create a space in the memory. Object can also be created when a class is defined by placing their names immediately after the closing braces. as we do in the structure. So we can declare the object like this one also, like we have done in the structure. That is, after finishing the class, after closing of the curly braces, we have or we are able to define the object that are known as variables of the class. This would create the objects x, y, z of the type item. This practice is seldom followed because we would like to declare the object close to the palace or place where they are used. Now, how to access the data members or the class members? So, how to access the data member that is available in the class, that is known as the class members. So, as pointed out earlier, the private data of a class, that is the private part, can be accessed only through the member functions of a class. So whatever the member function that is defined in the class, with the help of that we can define or we can access the private data, of a class. The main function cannot contain statements that access the number and the cost directly. The following is the format for calling a function, member function. There is a object name, then there is a function name, then there is a actual argument. So first of all there is a object name, then dot, then there is a function name, then there is a actual arguments, right? For example, this is the example. This is x dot get data, that is the object name is x because we have declared three objects x, y and z. So this is the x, then there is a dot operator, then there is a function name. But there are two types of functions in this example. One is get data, one is the put data. So first of all get data, and what the actual argument, that is 100, 75.5. There are two arguments, one is of 100, one is of 75.5. Is valid and assigns the value 100 to a number and 75.5 to a cost, because there are two members, one is a number and one is the cost. So 100 is assigned to the number and 75.5 is assigned to the cost of the object x by implementing the get data function. So whenever we implement the get data functions, these value will be assigned to the data members, that is the number and the cost. This assignment occurs in the actual function. Similarly, the statement x dot put data. So when we use the x dot get data, that is used for getting the value, storing the value. Then x dot put data is used for displaying the value on the screen, that is display the value of the data members. Remember, a member function can be invoked by using an object. The statement like this one, get data, has no meaning. Similarly, the statement like this one is also illegal. Although x is an object of the type item to which the number belongs, the number declared as a private can be accessed only through a member function. That is, the data members can only be accessed through the member function that is given, that is declared inside the class. It may also be recalled that objects communicate by sending and receiving the message. So whenever when we studied the object-oriented programming approaches, we have already studied that the object may communicate with each other, that the object communicate by sending and receiving the messages with each other. That is achieved, or this is achieved by through the member functions. That is how one class members can deal with another class member, or how one member class or one class member can access the values of that class only. That can be accessed by using the member functions. So for example, x dot put data, that sends a message to the object x requesting it to display its content. A variable that is declared as private can be accessed by the objects directly. Example, this is the example. There is a class xyz that is declared, and there are three data members, that is two data members, that is x and the y. And there is one data member that is declared, one more data member that is declared, that is a public part, that is a z. So two are of private, one is of public, and then there is a closing of the class, right? Now if we use xyzp, that is p is an object of the class, right? Now if I use p dot x equals to 0, so that means we can access the x value with the help of the object. No, that is not possible. Why? Because the x is a private part. Only the public members, only the member function, that is a public part, only the data member, that is a public part, can be accessed by using the object directly. That is, the object may communicate with the data members directly if that is of public part. Otherwise, the member functions are used to access the data members of the class. and this is okay, that is p.jet. Why? Because jet is of public part. Note, important point, the use of data in this manner defines the variety of data hiding and therefore should be avoided. Now, how to define the member functions? We have declared the member functions in the public part. Now, how to define the member functions, or how to give the definition to the member functions? So, member functions can be defined in two phases. So, there are two phases in which we can define the member functions. First is outside the class definition. One is inside the class definition. There are two parts in which we can define the member functions. One is outside the class, one is inside the class. Now let's see what is outside the class, how it is used in the outside the class. Now first is how the class will be defined, or how the member function will be defined outside the class and inside the class. So first is outside the class definition. This says member functions that are declared inside a class have to be defined separately outside the class. The definitions are very much like the normal function. That is, their definition is very much like what we have defined with the normal function. They should have a function header, function body. Since C++ does not support the old version of function definition, the entire prototype form must be used for defining the function header. An important difference between the member functions and the normal function. So what is the main difference between the normal function and the member function? Is that a member function incorporates a membership identity label in the header. So that means identity label means the private or the protected, it is available in the header. This label tells the compiler to which class the function belongs to, the general form of a member function. This is the difference, that is the visibility level or the identity label is available in the header, that tells to which, or the function is belong to which class. So the general form of a member function is, there is a return type, that is a return type means the return data type. Then there is a class name, that is the name of the class to which the function belongs. In between there is a scope resolution operator, and there is an argument declaration. So return type, then class name, then scope resolution operator, then function name, and then argument declaration. Then there is a function body, that means defining the function. The membership label class name tells, that is this one, tells the compiler that the function name belongs to the class name. That is, the scope of the function is restricted to the class name specified in the header line. The symbol, this one, that is the scope resolution operator, is known as the scope resolution operator. For example, consider the member functions, that is the get data and the put data, are discussed above. This is the example. There is a return type, that is a void. What is the class name? That is the item. Then there is a scope resolution operator. Then there is a get data, that means the member function name. Then there are two arguments that is used. One is the a, one is the b, both of integer type. That is a int a comma int b. Then there is a definition of the function, that is the number equals to a. That means assigning the a value into the number, then assigning the b value into the cost. That is, cost contains the b value and the number contains the a value. Then void item put data, that is the next function, that is a void item put data, that is the next part. Then cout number equals to number, cout cost. Since these functions do not return any values, the return type is void. The function arguments are declared using the ANSI prototype. The member functions have special characteristics that are often used in the program development. That is, a member function that is declared, that have been used in a proper manner, in a proper characteristics that is used in the development programs. What are the various characteristics? The first characteristics is that several different classes can use the same function name. That is, more than one class uses the same function name that is defined. The membership label, that is a public, private, protected, will resolve their space. That is, different classes have the same function name. For example, if we declare the function as a get data, that is also declared in another class. So multiple classes have multiple or the same function name. So how we can differ the function name? That can be differed by the membership label. Then next point says member functions can access the private data of the class. As we have discussed from the last 10 minutes, that is a member function that is declared in the class can only access the data members of the class. A non-member function, that is if it is not a member of the class, cannot do so. However, an exception to this rule is a friend function that is discussed in the later on. Next, a member function can call another member function directly. That is, if I want to access another member functions with the use of one member function, they can be used directly without having the dot operator. So it can be accessed by in any way. Now, this is how the member function is declared outside the class. Now, when it is declared inside the class, that is inside the class definition. So another method of defining a member function is to replace the function declaration by the actual function definition inside the class. So what is another method? That is to replace the function declaration by the actual function that is defined inside the class. For example, if we could define the item class as follows. This is the example. That is a class item, then there is a int number, float cost, then there is a public. So this is the private part and this is the public part. The public part is void get data. That means the get data is the name of the function. This is the declaration. This is the inline function. Then there is a put data that is displaying the numbers. So when the function is defined with the inside the class, it is treated as a inline function. This is example that is used with the C++ program with the class.